everyone, Sam from Developing Mathematical Thinking, and in this video today we're going to look at multiplying with decimals. And so the problem we're going to work on is 36 3/10 multiplied by 2/10. And we're going to look at multiplication with decimals the same way we looked at multiplying with whole numbers. The key idea here is if you haven't seen our videos on some decimal concepts or the 10 rule, specifically the 10 rule with decimals, you may want to check those out because they're going to connect to these ideas pretty directly. So we've got our area model up here, and you might notice that I've tried to draw it somewhat proportional, but if you think about this length of 36 3/10 relative to the size of 2/10, that's a pretty dramatic change in the sizes of each of those measurements. So it's not exactly accurate. So this 2/10, I've actually drawn it a little larger than this length of 3/10, and that's just because of the space available. So when you're multiplying with area models with decimals, oftentimes it's going to be hard to make it exact, but at least trying to is pretty helpful. So just trying to preserve those relative sizes. Then here I'm going to use partial products. Now traditionally when we multiply decimals, we often multiply by powers of 10 to change them into whole numbers. You might have heard this step called moving the decimal. Really, you're just increasing the place values. And then when you get that final product, you divide those out. Today, I just want to demonstrate that you don't have to do that with decimals. You can apply the 10 rule to still keep them in their original form and not change them by powers of 10. The reason why I like just exploring that idea, even though you certainly could multiply them to whole numbers, but I like exploring keeping them as the numbers we started with, because then you don't divide out those powers of 10 at the end. And that's often a really common misconception when kids get to division with decimals, is they think because when you multiply, you have to undo that at the end. They think that you're going to have to undo something with division. And one of the key parts of the DMT framework is to address misconceptions. So we're gonna force ourselves to keep those numbers as decimals. Then after we complete both of these methods, I'm going to move to the ratio table and show you how it's such a powerful tool for multiplying. And we're actually going to look at it two different ways. Okay, so let's start here with our partial products. And I would typically prefer to start with the larger place value, just because it's a little bit easier. The hardest math here is with the decimals, but we're going to focus on following the same steps we would if it was the traditional algorithm. So we're going to say, well, I know that 2 times 3 is 6. So 2/10 times 3 would be 6/10. So 2/10 times 3/10 will be 6/100. And we have a 10 rule video that models why that actually happens. Then I'm going to move over to the 2 times 6. Actually put this section right here in the area model. Forgot about that. So now let's come back here. Now we're going to multiply the 6 by 2/10. So I know that 2 times 6 is 12. So 2/10 times 6 is going to decrease by a place value to be 12/10. And the way we write 12/10 is that we have 1 and 2/10. And then I'm just going to put that 0 digit just to keep everything consistent with all the place values that I'm showing. Now we move to the 30 and the 2/10. Well, I know 2 times 30 would be 60. So 2/10 times 30 is going to decrease by a place value to be 6. And so we have these areas. There's the 12/10 or 1 and 20/100 is how I've written it. And then here's where the area of 6 will be. And then we're going to add those back together, all those partial products, and we end up with 7 and 26/100 is what the product is. Okay, so now that we've completed the area model with the partial products, because those two really link directly together, we're going to work with the ratio table now. We're actually going to do two different ones. But I'm going to start with the one that probably requires the most steps, just to show some different ways we can kind of think about this. So what I'm trying to do is I'm trying to take 2/10 and iterate or copy it 36 3/10 times. So we're going to be increasing the 2/10 by quite a bit. So what I've listed here is just, well, 1 times 2/10 is 2/10. That just gets us started. And I realized that it's going to be a pretty big jump to get up to 30. And one thing you can do is just list what multiplying by 10 would be. And I like doing that when we deal with decimals because that helps us get focused on that 10 rule idea of increasing the 2/10 to 2. And then I could maybe double that again to get to 20, and that doubles the 2 to 4. And then if I compose those together or multiply by another 10, I get the 30 from the 36, and there's the 6. And here we end up with that partial product in the area model, just a slightly different process. So I've got the 30. To get to 6, I could just do 6 times 2 and then decrease it by a place value. But I could also list something like multiplying by 3 and then doubling that. There's a lot of different options. I'm going to try to reinforce that 10 rule idea though. So I know 6 times 2 is 12. So 6 times 2/10 will be 12/10, or 1 2/10. And there's that section and then that partial product from the other methods. Now I've got the 6. And so the last part I need to do is the 3/10. And in this case, you could actually say, well, the 3/10 is difficult to think about. So I'm just going to multiply by 3. Okay, well, if multiplying by 3, that would be 6/10. And now I can decrease this by a place value using that 10 rule. And now I have the 3/10. And if I recompose the 30, the 6, and the 3/10, I get the 36 and 3/10 multiplied by 2/10. We've already added up the partial products, and we find that that is the same product. Now, the other way to think about using the table, that was a lot of work, but it really builds some good flexible thinking, and it keeps kids kind of safe to the things they're comfortable with working with. But I can also use the commutative property to actually solve this problem in very few steps. So instead of multiplying by 2/10, I'm going to find 2/10 of 36 and 3/10. And one thing I can do is just double that to use the 2. And I could add the 36 and 3/10 over here on the side, but we always try to press kids conceptually to get them to think about patterns and relationships and be flexible in their mental math. So another strategy I could do is just double the 30 to 60, double the 6 to 12, that gives me 72, and then double the 3/10 to 6/10. And now, using the 10 rule, just like we did up here and in these other methods, I can now decrease that by a place value, which means the 72 and 6/10 also has to decrease by a place value, and we end up with our product just like we found in all the other methods. I hope this was helpful, and if you want some more information on the 10 rule, again, we do have some videos on that, and then as well as some videos on some decimal concepts that might be helpful.